All right, last one. So tangent and cotangent. So remember that these ones have a period of 180. So that's one of the main differences. Um, and then remember that, let's see, for tangent, the asymptotes usually happen 90 and then every 180 from there. And then for cotangent, it's every 180. All right. So here this isn't an amplitude. There is no amplitude with tangent and cotangent. But this does mean it's going to be a vertical stretch by a factor of 2, right? So that does mean it's going to be a little steeper. You don't have to worry about that too much. But let me factor out a 1/2 here. So I'll get theta plus 315 times 2 is 630. Okay, plus 1. So the period is going to be 180 times 2, right? So opposite of dividing by a half is multiplying by 2. So that would be 360. Okay. So tangent usually starts in the middle, goes up, and usually we have our asymptotes at negative 90. But now it's going to be stretched basically by a factor of 2 horizontally, so it's going to be at 180. Okay, and then usually I would add 180 to get to the next point. But since my period's stretched by 2, it's going to be 360 for the next one. So 180 plus 360 is 540. Okay, and then between those two, right here is where it's going to cross 0. Okay, now all this is great except for the fact that we moved left 360 or 630, excuse me. Okay, so left 630. So all this stuff is going to move left 630. So 540 minus 630 is negative 90. So it'd be like actually over here, right? So there'd be an asymptote here, 90, and then so all these will basically shift over 90. So let's see. All right. So this will be here. Let me erase this other stuff. All right. So, and then remember that it moves up 1. Right. I don't know about remember because we didn't talk about that yet, but it moves up 1. So that's a vertical shift. So that'll be the new midline. Will be up 1. All right, and so it's going to cross through right here. Tangent goes up on the right, down on the left, so it'll go something like this. Okay, and then you'll have something like that on the other side, so we'll just kind of draw a little bit of that here. And then we know that on this side it's going to be going up, so kind of draw a little bit of that here. All right, so that's tangent and all of its characteristics there. So cotangent, same thing. Amplitude is non-existent. It does have a vertical stretch by factor 2, so it might be a little steeper than usual, or it will be steeper than the parent function. So the period. So here I have you can factor out a 2, so it's 2 theta 75, and so our period is going to be 180 divided by 2, which is 90. Okay. And then our phase shift is left, and it's going to be 75. So it'll be left 75. All right, and our vertical stretch is going to be up 2. Our vertical shift, excuse me, up 2. Okay, so our new baseline is going to be right here. All right, we're going to go left 75. So normally with cotangent, we have 180 is where we have our asymptotes, and at 0, of course, as well. So let's see. So if a period is 90 instead, it's going to shrink it, right, by half. So instead of happening at every 180, it's going to happen at every 90. So that would be right here, right, normally, except it's moving left 75. So normally it would be right here. I want to move it left 75, so that'll get it to be about right here, right? All right, and then every 90, so I'm going to have 15 plus 90 is 105. Plus 90 is 195. 195 plus 90 is 285. All right, and so remember that with cotangent, it's going to go, so we'll go right in the middle here. And cotangent goes down on the left, okay, up on the right. So we're going to have something like this, looks like this. Right, so it doesn't have to be perfect. It kind of has those main features that we talked about. All right, so that's how you graph tangent and cotangent. So let me know if you have any questions, and we'll practice this in class.